We've now got a pretty good number of tests written around our lottery contract. In this video, we're now going to start to pivot to working on a web application front end that a user can make use of to interact with this lottery contract. So this is where the Ethereum stuff starts getting really interesting. In order to put together a front end for a user to interact with this contract, we are going to be making use of the React.js view rendering library. Now your first question might be, why React? Why are we using React here? What is the purpose of React? You might have signed up for this course thinking, oh yeah, we're going to do just Ethereum stuff and some basic JavaScript, and now you're telling me we need to make use of React? Why is that? In this video, I want to make it really clear why you and I are going to be using React to create an Ethereum application. And I think that in the end, you will agree with me that React is a very, very good technology to use with Ethereum. We're going to first start off by talking about the architecture around a traditional application. So a traditional web application that does not use Ethereum at all. So here is some very traditional architecture that you will see in the vast majority of web applications that exist in the wild right now. We might have some server. A user can access this server, and the server will respond with an HTML document and maybe some JavaScript assets. The user will then mess around with the application, and eventually they will want to modify the data that exists inside the application. Maybe they want to click on a button that says, I want to add a new to-do, or whatever it is. They want to modify some amount of data. So when a user clicks on that button, that will traditionally send some type of request to our server, and we will create a new to-do inside of some persistent database. So that whenever a user comes back to our application again in the future, they'll see a new to-do added on their to-do list. So the entire idea here is that anytime we want to write data to a traditional application, we will always send off a request to some server, and that data will be written to some database. And it does not matter if writing this data or sending this data to the server takes the form of a classic HTML form submittal or takes the form of an AJAX request. No matter what, it always gets sent to the server, and that data is persisted to the database. So with this traditional architecture, everything revolves around this server that you and I would put together. So let's now talk about how the Ethereum world takes this approach right here and really turns it on its head. All right, so here's a very similar diagram, but with a couple of little changes to it. So with an Ethereum sort of architecture, we can certainly still have a server, but its role is dramatically diminished. The server does far less work than it did in the past. In this sort of world, our server can still send a HTML document and some JavaScript assets down to the browser. The user might interact with our application in some fashion, and then at some point in time, they'll click on, say, a button, and that button is intended to change the data that is related to our contract. Maybe they want to enter into a lottery, or they want to add a new to-do to a to-do list, or they want to create a new blog post, whatever it might be. In the Ethereum world, whenever a user tries to change some data, they do not reach back out to our server. The server is not at all involved in that process. Instead, the Ethereum application running inside the browser will make use of Web3, which communicates with MetaMask. MetaMask creates a transaction, signs it with the user's private key, and sends that transaction to the Ethereum network. The very important and critical thing to understand here is that the only way for a user to change data is through the use of their public and private keys. Remember, anytime a user changes data, they have to send a transaction to the network, and that costs some amount of money. And chances are you want your users to spend that money. You don't want your application to spend that money. These public and private keys only ever exist on the user's machine. The public and private keys will never, ever, under any circumstance, be sent to your server. You will never receive private keys from your users. So your server is no longer going to be responsible for writing any data to a database or to the blockchain or anything similar to that, unless you specifically want your server to do so. However, if your server is doing that, it will be by using your set of private keys. It will not be done by using your users. Your user will never send you their private keys. So essentially what we're doing with this Ethereum architecture is moving all this responsibility of writing data to some database or to some persistent database from the server over to the client. And that means that the client needs to get a lot more intelligent, and it needs to have a lot more functionality built into it than it may have had in the past. In the past, with a traditional web application, we could build a server that sends down some silly HTML document with no JavaScript, and we can make use of plain HTML form submittals to allow users to change data inside the application. And so that meant that our web application on the browser might have been very simplistic, no JavaScript whatsoever, just plain HTML. And we absolutely could get away with that back with this traditional architecture. But with this new way of doing things with an Ethereum architecture, because the client must be responsible for modifying any data inside of our application, it means that all the code that we write is going to be focused around running in the user's browser. So what that means is we need to use libraries, we need to use technologies that are all focused around putting more logic and more code, more business logic inside the browser than we had in the past. So that is why we are going to be using React in this course. We're going to use React because it makes our lives of writing complex applications in the browser much easier and much more straightforward. Now, just so you know, as a quick aside, when I wrote this course originally, I tried very hard to get away without using any React code whatsoever. I tried very hard to stick to just vanilla JavaScript code and put together all the applications that you and I are going to build by using simply vanilla JavaScript. However, I'll be completely honest with you, I found that the process was extremely challenging, and I think in the end it would have been much more challenging for you to try to write the applications that we're going to make by using just vanilla JavaScript. I'm saying that because if you're thinking, Steven, I don't want to learn React, I don't know React, I don't want to deal with it whatsoever, well, honestly, at the end of the day, your life is going to be a lot easier if you try to pick up a little bit of React right now, rather than trying to build the applications that you and I are going to be making by using vanilla JavaScript. So, in a nutshell, that's why we're using React. It really makes writing these complex applications much more straightforward. Now, having said that, you might be sitting there thinking, okay, fine, I get it, we're going to use React, I understand, but I don't know it. I don't know React at all. Well, don't worry, I got you covered in this course. So, here's what you're going to do if you are not familiar with React, or if you feel like you need a little bit of a refresher. If you feel like you need a refresher with React, or if you've never worked with it in the past, that is totally okay. In this course, at the very last section, I put together a collection of many different videos that are going to quickly get you up to speed with React. So essentially, I took a couple of videos from another course on React that I have, and I stuck them at the end of this course. So if you feel like you need a brush up or you've never touched React before, you can pause this video right now, go to that last section in this course or the last collection of videos, find that appendix and do a quick run through of those videos, and they will very quickly give you all the knowledge you need to know about how to write React and how to work with it. All right, so that's pretty much where we're going to leave it for right now. Again, I know that you might be a little bit frustrated to hear, well, hey, out of the blue, you need to know React to get through this stuff. But again, I'm doing this for a very, very good reason. And trust me, I tried really, really hard to not have to use React. I really wanted to use just vanilla JavaScript for the web front ends that we're going to build. But at the end of the day, it just really had to be done. React is the right way to do this stuff. Certainly, if you wanted to use Angular, hey, you could definitely do that. But honestly, I think it's a lot easier to get started with React. So I think that we've got a plan going forward. Again, if you need a refresher, go to that appendix section. Otherwise, I'll catch you in the next video, and we're going to start talking about exactly how we're going to approach a web front end for our lottery application. So I'll see you in just a minute. If you're at this video, hopefully you have either got a background with React or you've gone over to that appendix section and went through that quick application. Either way, hopefully we now have a good understanding of some of the basics of React. And at this point, we really only need to know about React, no need to be concerned about Redux or React Router or anything like that. The first thing we're going to do in this video is install a little boilerplate generator, which we'll use in just a moment. At my command line, I'm going to run sudo npm install -g create react app. If you are on Windows, you do not need to include the sudo right here. So if you're on Windows, you can omit that. I get prompted for my password, I'll enter it, and that starts up that process. Now we'll talk about Create React App's purpose in just a moment if you've never used it before, but while this installation is running, let's flip back over and talk about the application that we're going to be building using our lottery contract. So here's a mock-up of the application we're going to make. Yep, this is it, pretty straightforward in nature. This first application is going to be focused entirely on how we interact with Ethereum contracts using JavaScript code. So this is much more focused on some of the nuts and bolts rather than making a very pretty looking application. I can guarantee you that the next app we're going to work on is going to look really neat and very nice, but for this one, we're going to be focused much more on the functionality side of things. So there's a couple of notes I want to give you around this application. And let's take a look at some of them. At the very top, we're going to have a little bit of text that is focused around informing the user about the status of our contract. So we're going to say who the manager of the contract is. Notice that it's going to be the manager's address as opposed to any name or anything like that. On the line underneath that, we'll then state the number of people who have entered the contract and also how much money is currently inside of the prize pool. Most of this information right here can be retrieved through calls to our contract. Remember that a call is a read-only process for obtaining some information from an individual contract. So that's what we're going to do for most of the stuff at the top here. Now the next two sections are going to be a little bit more interesting. The next one down is going to enable users to enter into the lottery. So our users should be able to enter in some text right here or some amount of ether that they want to use to enter into the contract. They should then be able to click on the enter button and then somehow enter into the contract itself. Essentially, we want to call the enter function on our contract. Underneath that, we'll have the section that is intended for use by the manager of the application. So it's going to be a button that calls the pick winner function. Remember that the pick winner function can be only invoked by the manager of the contract. So in theory, we really only want to show this section right here if the user who is visiting this application is the manager. That would be really nice to do, but for our first time through this application, we're going to keep things simple, and we're going to say that no matter who you are, whether you are the manager or not, we're going to always show this section right here with a button that says pick winner. In the future, we'll figure out how to do some more conditional rendering to decide whether or not to show a given element. Then at the very bottom of the page, we're going to have a little status text area. So for example, after clicking on the pick winner button right here, we might show the address of the person who won or something similar. The status text area is going to be used to inform our users about what is currently going on with the contract. Remember, whenever a user tries to modify data inside of our contract, that issues a transaction to the network, and it can take anywhere from 15 seconds to 30 seconds or so for that transaction to be processed and cleared. So we need to make sure that our users are reasonably aware of what is going on inside the contract as they start interacting with it. And for that, we want to show them some status information and say, okay, we're currently entering you into the contract, or maybe after clicking on the pick winner, we then say, okay, a winner has been picked and here's who they are, or whatever it might be. Essentially, we just want some practice of informing our users about when a given operation has been completed. For this first application, we're going to take this very simplistic approach of showing some text status, but in the future, we will instead use spinners and more complex messages to give our users a better idea of what is going on and make our application a little bit more dynamic and lively. Now, the last thing I want to remind you about here is that in this course, we're going to be using the Rinkeby test network for just about everything from here on out. We're using Rinkeby so that we can get a very realistic idea of how long these transactions take to be processed. As I said much earlier, a lot of people tend to develop these applications, like these web front ends, using test networks that run locally. And those local networks always process transactions instantaneously. All that really does, it makes the development process a lot smoother and a little bit faster because your transactions clear instantly. But at the end of the day, that usually means that you just end up developing your applications under the assumption that your users will see transactions clear instantly. And so my personal belief is that that leads to some poor development practices or poor user interfaces because you are not really using the application as your users will use it. So that's why we're going to use Rinkeby. We really want to see those delays and understand how they affect how users use our application. All right, so that's a little bit on what's going on here. Now, the last thing I want to do is use that Create React App tool that we just installed a moment ago to generate a new React project. So if you are here in this course, having already gotten some experience with React, chances are you've heard of Create React App, but if you just went through that appendix section, you may or may not have heard of the Create React App tool. So this tool right here, Create React App, is a command line application that is used to generate a new React application. And we're going to use it to generate a new little project that is going to serve as the front end for our application. I'm going to make sure that I am outside of our lottery directory. So at my terminal, you'll notice that I am not inside that lottery project anymore. So I am in a parent directory. Out here, so in this parent directory, we're going to generate a new React application by using the Create React App tool. So I will run Create React App and then the name of my project. And we're going to name this Lottery-React, like so. So we're not going to use the same project folder as we did for our testing setup and all the contract stuff. This is going to be a one-time thing, and the only reason we're making these two separate folders is because of the way that Create React App works. Unfortunately, Create React App, when we generate a project with it, it doesn't make it very easy to integrate other code bases like our existing lottery contract right here into it. On the next project we work on, we will be making a single folder, like a single repository that is going to house all of our project code. It's just for this one that we're going to do things a little bit differently. And again, it is because of the way that Create React App works and some limitations in our ability to require in or make use of JavaScript files across folders. So just a little technicality. All right, so we'll run this command and we should see some text about creating a new React app in this given folder. It will then start installing some modules right here, which will take a couple of minutes. So let's pause here and we'll continue in the next video and start writing this new application. In the last video, we generated a new React project by using the Create React App command line tool. In this video, I want to continue by doing a quick overview of some of the different project files and folders that were generated by that tool. If I print out my list of directories, I should see the Lottery-React folder that was just created by the command line tool. I'm going to change into that, and then I'll start up my code editor inside of this directory. All right, so here is my code editor, and we're going to take a look at some of the different project files and folders that were created inside of here. You'll notice two folders right away, the public directory and the SRC directory. In the public directory, there's only one file that we're going to care about for the purposes of this application, and that is the index.html file. This is the root HTML document that is going to be loaded up anytime someone attempts to visit our application. We won't do too much inside this file, but I do want you to know that it exists. Inside the SRC directory, you'll see a collection of JavaScript files and CSS files as well. The most relevant file that we're going to be doing a lot of work on is the app.js file. If you open this up, you'll see a component. And hopefully at this point, this component doesn't look too scary. You'll see that it declares a class that extends the root component. There's a render method, and that returns some amount of JSX, which will eventually be displayed on the screen of our browser when we run this application. Let's flip back over to our command line and start up this application and just make sure that we can access it inside of our browser. So back at the terminal, I will run npm run start, like so. After a moment or two, you'll see a message appear on the screen that says starting the development server, and then your web browser will automatically kick up and open a new tab at localhost 3000. After another couple of seconds, the application will finally boot up and you'll see a screen like this appear. So this is the app.js component that we were just looking at a moment ago inside of our code editor. We're not going to use any of this boilerplate that you see right here. In just a moment, we're going to delete a lot of the code inside that app.js file. But I just want you to know, hey, this is what you should be seeing by default. All right, so let's pause here. We're going to come back in the next section and start modifying the code inside of this project to incorporate some different components of our Ethereum application. So we'll get started in the next video. Now that we got a quick rundown of the Create React App project, let's continue by installing the Web3 library. Installing the Web3 library is an absolute core pinnacle thing of every Ethereum application that you and I are going to put together. So over at the command line, I'm going to open up a second window. This is still inside of the same project directory of lottery-react. If you are using any other terminal besides iTerm, which is what I use, you can just open up a second terminal window and manually navigate back to the same project directory. Once here, we're going to install the Web3 library just as we did a little bit ago when we were writing our tests. So I will run npm install --save Web3, and remember we want a specific version. So I'll say Web3 at 1.0.0-beta.26. Now, one quick thing I want to throw out there before we run this command. If you have Yarn, the package manager Yarn, installed on your system, then rather than using npm install, you will want to run the command yarn add, and then the version that you want to install right here. So if you have Yarn installed, use Yarn here. Please do not use npm. The reason for that is that when you first generated your project using Create React App, if you have Yarn installed, it's going to use that package manager to install all of your projects, or excuse me, all of your dependencies. And npm and Yarn don't work together too nicely. So if you use npm to install this module right here, you will eventually end up with an error message in a couple of videos, and it will end up being really confusing. So I just want to throw that out there. All right, so we'll run this, and that will install Web3. Now we're going to wire this thing up inside of our application in just a moment, but before we do, I want you to have a really solid understanding of how Web3 works inside of our project. I'm going to be completely honest with you. A lot of the value that I think you are getting out of this course is just having someone else to point out all the huge gotchas that you will run into as you start building your own Ethereum applications. And what I'm about to tell you right now is probably one of the most confusing things out of everything that we're going to cover, because there's very little documentation about how to address getting Web3 set up inside of a new project. So let's take a look at a diagram. All right, so here's what's going to be happening inside of our application. At this point, we have MetaMask running inside of our Chrome browser, right? Like here's MetaMask up here at the top right-hand side. We are signed in, we have an account, I have Rinkeby test network selected. Whenever MetaMask is running inside of your browser, it automatically injects the Web3 library into any active page, even the page that I'm on right now. So as you can see, I'm at draw.io, which is the service that I use for making these diagrams. If I open up my console and type in simply Web3, let's do that again, Web3, there we go. You'll see that, yep, Web3 is defined. So this Web3 variable right here has been injected onto the page by MetaMask. I can guarantee you that draw.io does not currently use Ethereum or anything like that. So this is not a variable that is coming from draw.io. It is coming from MetaMask. Now this version of Web3 that MetaMask makes use of is version 0.20, which you will recall is the earlier, older version that we don't really want to spend any time learning because it's old, it's out of date, and it's a completely different API. And it's much more painful to use because it relies upon callbacks. The good thing about this instance, however, is that this Web3 version that has been injected into our page has a provider already set up inside of it. And you will recall that provider is what allows us to communicate to some given Ethereum network. This provider, in this case, points to the Rinkeby test network. So if we go up here and we verify that Rinkeby test network is selected, that is what this provider is pointing to. So whenever we visit a web page with MetaMask installed, we instantly get access to a copy of Web3 that points to the Rinkeby test network. All right. So that's kind of point one to understand. We automatically get this version of Web3. So how is this going to work with our application? Well, kind of confusingly. So our application is going to be making use of Web3 version 1. Now, when we are using MetaMask on any given web page, MetaMask will always inject Web3 onto the page. So MetaMask is always going to take this library and inject it into the page. and there is nothing that you and I can do to stop that. We cannot stop that. So we need to make sure that whenever we start using Web3 inside of our application, we are using the correct version that we have installed to our project, which is version 1. We don't want to use the old, busted, nasty version 0.2. We want to use the version 1 that we just installed at the command line. But here's where things start to get tricky. Remember, MetaMask has access to all of our account keys and all of our, not only the public keys, but also the private keys. So although we are saying that we don't care about this older version of Web3 that has been injected onto the page at all, we actually kind of do care about it. The provider is what stores those account keys, all the private keys and the public keys. So rather than saying, oh, we want to ignore this thing entirely, what we actually kind of want to do is take our instance of Web3, version 1 down here that you and I are going to create, and we kind of want to tear out the provider that got injected onto the page with this other copy of Web3, if that makes any sense. So we want to create our version of Web3, and we want to hijack the provider that belongs to the injected version of Web3. And I know that probably sounds confusing, but at the end of the day, that's what we're trying to do. We want to use this other version of, or we want to use this provider because it's going to allow us to just take this provider that's already connected to Rinkeby and use it for all the different transactions that you and I are going to create. So that's the goal. Now this description might seem like it's really weird. It might be confusing. You might be saying, why? What's going on here? Well, fortunately, at the end of the day, all we have to do is really write one line of code to make this happen. We only have to write one line of code to take that provider from the existing instance and throw it into our copy. I just want you to understand why we are writing that one line. It is to make use of the provider from the version of Web3 that has already been injected on the page by MetaMask. Now, the last thing I want to mention here is that for this particular application, you and I are going to assume that the user always has MetaMask installed. So this is a very bold assumption because chances are 99.99999% of people out there who are using Chrome or any browser do not have MetaMask installed or configured. But for just this application, just this very first one that you and I are working on, we're going to take the easy way out and assume that MetaMask is installed. What that means is that this application will not be able to easily be deployed to some remote server and have your friends visit it. In other words, if you want to deploy this application and show it off to your friends, they will have to have MetaMask installed as well. On the next application that we build, we're going to make an application that will work regardless of whether the user has MetaMask installed. So for this first application we're going to make, we're going to take the easy way out, keep things nice and simple. For the next application, we're going to make sure that we have an app that works no matter what device the user is visiting from, whether they have MetaMask installed or not, doesn't matter. We're going to make sure it all works. All right, so that's the plan. Hopefully that doesn't sound too bad. So let's pause right here. We're going to come back in the next video and we're going to write the code that is going to create our local instance of Web3 and hijack the provider from the injected copy of Web3. So quick pause and we'll take care of that in the next video. In the last video, we discussed how we're going to kind of wrangle these different instances of Web3 inside of our application. We're now going to flip on over to our code editor and write some code that is going to set up our own local instance of Web3 and rip out the provider from the injected copy that is coming from MetaMask. And this is what is going to allow our instance of Web3 to automatically connect to the Rinkeby test network and make use of all of the accounts that have been assigned to the MetaMask extension. So this is really going to make our lives a lot easier in the long run. It's just kind of understanding what's going on. That's the hard part. Okay, so back inside my code editor, I'm going to create a new file inside of my src directory. This file is going to house all of our configuration code around the Web3 library. So I'm going to make a new file. I'm going to call it simply web3.js, like so. Then inside of here, we're going to import the Web3 library at the top of the file. So this is going to look very similar to a lot of the test code or the test setup that we wrote just a little bit ago when we were working on the previous projects. So we'll say import Web3 from Web3. And remember, this is the constructor function, so we have a capital W right here. Then underneath this, we're going to create a new instance of Web3. And at the same time, we're going to rip that provider out from the injected copy of Web3 that has been provided by MetaMask. So we'll say const lowercase Web3 is new capital Web3. And then to rip out that provider, we're going to write window.web3.current provider, like so. Window right here is a reference to the window global variable. As we saw just a moment ago, MetaMask injects Web3 onto the Web3 global variable. So this right here is the copy of MetaMask that is coming, or excuse me, the copy of Web3 that is coming from the MetaMask library. And then the current provider property is, as you might guess, the provider that is installed or given to that copy of Web3. So this provider right here has been pre-configured to connect to the Rinkeby test network, and it has access to all of our account addresses, keys, public keys, everything we could possibly want. So we're taking that provider, we're giving it to our local copy of Web3, and that gives us a copy or an instance of Web3 that has been pre-configured and completely set up with no additional work required from you or me. Now, the very last thing we're going to do inside this file is export that thing. So we'll say export default Web3. So now any other file inside of our application can require or import this web3.js file, and it will get this pre-built, already configured, 100% setup version of Web3 that is the most recent version, version 1, or at least, most recent version as of the time I'm making this video. Cool, so that looks good. Now, maybe the last thing that we should do is to import this thing into our app.js file, and then maybe console log out the version of this Web3 thing right here, just to make sure that it's working the way we expect. So I'm going to flip on over to my app.js file. I'm going to import Web3 from, and in this case, it's going to be from that Web3 file. So we're not working with the Web3 library or the package anymore. We're now working with the file Web3. So I'm going to say ./Web3, like so. Then how about inside the render method? I think that's a reasonable place. We'll say console.log web3. I think it's the lowercase version is the version. So let's now flip back over to our browser and see if we can get this console log to show up. All right, so back over inside my browser, you'll see that the page automatically refreshes. I'm going to open up my console, and there we go. So there's our version 1.0 beta.26. And if we want to, we could print out, say, a list of all of the accounts that are tied to this instance of Web3. So I could say web3.eth.get accounts. Remember, this returns a promise right here. Normally, we make use of the async await syntax, but we can't use async await with the render method of a React component. So instead, I'll chain on my promise. I'll say .then, and we'll just pass in console log, the function. Notice that I do not have a set of parentheses here. I'm going to just pass everything directly into console log. And that means that anything that getAccounts retrieves will be automatically logged to the console. So if I now go back over, the refresh already kicked in, and I'll see a console log of my account address. So clearly we have correctly set up our instance of Web3, and we have clearly ripped away or kind of hijacked the provider that was injected onto the page by MetaMask. And just to make sure, I will open up MetaMask and double check my address. Yep, so you can see CF019, CF019. All right, so like I said, this was, believe it or not, probably a lot of the value that you get from this course is me just telling you these things, because honestly, there is no other resource out there that says, hey, here's how we get our own version of Web3 working whenever we are using MetaMask. A lot of other resources out there say, oh yeah, you just got to use whatever version MetaMask is going to give you. But obviously, you and I want to use our version. We don't want to use the version that is coming from Web3, from MetaMask, because over time, MetaMask is going to change the versions used by Web3. And heck, it's even supposedly going to eventually deprecate the internal copy of Web3. All right, so let's pause here. We'll continue in the next video, and we're going to start making use of this instance of Web3 to retrieve some information from our contract. So quick break, and I'll see you in a minute. In the last section, we were able to configure our own local copy of Web3 by using the injected copy provided by MetaMask. I'm inside my app component right now, and I am going to clean up that console log that we left behind, because I personally just don't like leaving dangling console logs. In this video, we're going to continue by taking the lottery contract that we had already put together and somehow getting it to work with our React application. So this is where the really important knowledge comes in. This is going to be where we figure out how to take some data from the Ethereum blockchain and make it available to our actual React project. In order to do this, we're going to go back to the previous project we worked on, like the lottery stuff with all the tests and all the deploy scripts and all that stuff. And we're going to work with that a little bit and then access that stuff from our React project. Let's first start off by taking a look at a diagram that's going to help you get a good idea of exactly what's going to happen. I want you to first recall that the lottery project that we just finished up with all those tests and whatnot had two additional scripts set up inside of it. It had a compile script and it had a deploy script. The compile script took our lottery source code, like the Solidity source code, it compiled it, and that generated both an ABI, which we also refer to as the interface, and it also created the contract bytecode, which is used to deploy our contract to the actual network. That interface, or that contract ABI, can be thought of as our interface layer, or our communication layer, or the translation layer from the blockchain world to the JavaScript world. So very shortly, we're going to go and take that ABI and we're going to feed it into our Web3 instance. This is going to create a local copy of the contract, and it's going to essentially tell our Web3 instance, hey, here is a contract and here's how it behaves. Here are the different functions. Here's what they require as inputs, and here's what they provide as outputs. That's going to create a local copy of the contract. We're then going to deploy our contract, and we're going to then tell Web3 what address the contract was deployed at. So remember, anytime we deploy a contract to the blockchain, the contract always gets a distinct address assigned to it. So we need to not only instruct Web3 about how the contract can be interacted with through the interface, but we also have to tell Web3 about where the contract lives on the blockchain. So the end result is that Web3 will be able to communicate with our deployed lottery instance that exists on Rinkeby, and we can call different methods, different functions on it, whatever we want to do. So that's the general idea. Clearly, the first thing that we need here is to not only get access to our contract interface, but we also need to deploy our lottery contract and get our address from it. So with that in mind, let's flip on over to our terminal and our code editor, and we're going to find those two pieces of information. All right, I'm going to change back over to my code editor for the lottery contract. So here it is on the screen. So notice I'm now back inside of the original lottery project that you and I were working on a handful of videos ago. Here's the test file. We don't really care about the tests anymore. Here's the contract source code. Again, we don't really care about this anymore. What we really care about is the deployment script and the compile script. So we're going to deploy this contract, and we also want to make sure we get a copy of the contract ABI. I'm going to scroll down just a little bit and find where we created and deployed the contract. So here it is right here. So I definitely want to make sure that after we deploy the contract, we then console log out the address that the contract was deployed to. So notice right here, after we do the deployment, we console logged out where it got deployed to. Do make sure that you have this console log here, because we do need to get that address. The other thing that we need to get access to is the contract interface, which you will recall is available in this file as the variable interface. So to get access to that thing, I'm just going to add on another console log, and I'll console log out the interface. So now we can run our deployment script, and we'll get a console log in the terminal of our interface, and we'll also get a console log of our contract address. So let's now flip on over to our terminal. We're going to run this deployment script, and then we're going to take those two pieces of information and add them to our React project. All right, so I'm going to go back over to my terminal. I'm going to go back to my lottery directory. Oops, lottery, there we go. And then inside of here, I'm going to run the npm script that we had put together. You will recall inside of our package.json file, oh no, we never put a script together for that one, my mistake. So to deploy our project, we can run simply node deploy.js, like so. So this will compile our script and then attempt to deploy it out to the Rinkeby test network. Now, if you remember, this takes like about a minute or two, so we'll pause the video right here, and we'll come back in a second, and we'll take the information that gets console logged and add it to our React project. All right, so I'll see you in just a minute. At the end of the last video, we ran our deployment script, and you should now see inside of your terminal both the contract interface, which will be a big block of text like so, and you should also see the contract address. So this is where the contract was deployed to on the Rinkeby test network. We're now going to copy paste both the ABI and the address and add them to a new file inside of our React project. So I'm going to change back over to my code editor. I'm going to make sure that I am inside of the React project. So I definitely am. And then I'm going to create a new file inside of the src directory. So I'll make a new file and I'm going to call this lottery.js. At the top of this file, we'll first start off by importing our Web3 instance. Remember, the entire goal of this is to set up a local copy of the contract that refers to the correct address on the Rinkeby test network. And Web3 is an integral part of making that connection. So we're going to import Web3 from ./Web3, like so. Then underneath that, we're going to console log, or excuse me, we're going to copy paste over the address and the ABI that we just console logged out at the terminal. So I'm going to go back to my terminal. I'm going to highlight the address and I'm going to copy it. I'm then going to go back over to my code editor. I'll make a new variable called address and I'll paste it in like so. And then I'm going to repeat the same process for the contract ABI. So underneath that, I'll say const ABI. I'll go back to my terminal. I'm going to copy the entire ABI from the first square bracket to the bottom square bracket. I'll copy this. I'll go back over to my code editor and paste it. Now, when you paste it, you'll probably see it appear on the screen a little bit like this. So everything kind of condensed down to one line. I personally am running a code formatter inside of my editor that automatically runs anytime that I save a file. So I'm going to save the file right now, and when I do so, you're going to see all of my code kind of jump and reformat itself on the screen. If you see your code looking like this, that is totally fine. So you do not have to reformat or do anything to what you see. This just happens automatically for me because it's a plugin that I use. And just in case you're curious, I use Prettier. It's spelled Prettier. You can always go and look it up and install it in your own editor if you want to. So if your ABI does not look exactly like this, if it's all kind of scrunched up into one or two lines, that is totally fine. You don't need to reformat it or anything like that. Okay, now the last thing we're going to do inside this file, we're going to take the address and we're going to take the ABI. We're going to use that to create a new local contract instance using the Web3 library. Now, the thing I want you to remember here is that when I say a local contract instance, it means we're going to make an object that exists only inside of our browser that kind of functions as an abstraction or a representation of our deployed contract. So the object that you and I are going to create is not the actual contract that exists on the blockchain. It is a local JavaScript only copy that is meant to represent what is actually occurring on the blockchain over here. So you can kind of imagine that what we are going to create will be something over here that looks like, you know, local copy of that contract or something like that. This local copy will be created by using the contract ABI that we just pasted in and the address that we just pasted in as well. So we can really imagine that this local copy refers over to this copy that exists on the blockchain. All right, so let's give this a shot. I'm going to go back down, or I'm going to go back to my lottery.js file, and I'm going to scroll to the very bottom of it, where we will create this new local instance of the contract. And we're going to export it from this file at the same time. So we don't really care about working with a contract in this file at all. The only purpose of this file is to create the instance of the contract. We're then going to work with it from the React side of our application. So down here, we will say export default, new web3.eth.k capital C contract, and then we will pass in the ABI and the address, like so. And of course, I will save the file as well. All right, so now this lottery.js file exports a complete copy of our contract that we can work with from the React side of our code base. So this thing right here, this thing that we just created and exported, is essentially our window or our portal, our access to our contract that actually exists on the blockchain. This line of code right here, specifically the web3.eth.contract, should look pretty familiar. You will recall that we wrote the same line of code when we were just working on our test project, or all the testing code, a little bit ago. So just as we did before, just as we created a copy of our contract, we're doing the same exact thing over here as well. So all the same methods that we were using inside of our test code, like say, let's go pull those up, why not? So here's our test file right here. So before, when we called things like say lottery.methods.enter.send, all the same code can now be used from the React side of our application. So if from the React side we want to enter into the lottery, we can basically write this exact same line of code right here inside the React project, and it's just going to work for us, period. So that's why I was really excited to write these tests. I know the tests are boring, but they give you a good sense of how to interact with Web3. So now you've got all that knowledge, and we can immediately apply it to the React side of our project. All right, so let's pause here. We're going to come back in the next video, and we're going to start to customize the app component to show some information about our deployed contract. So that's where we're going to really connect the Ethereum and the React world together. So see you in just a minute. In the last video, we put together our lottery contract inside the lottery.js file. Now we can flip over to our app.js file and import that at the top. So I'll say import lottery from lottery, like so. Now that we have access to this object inside of here, we can interact with the contract to receive information from it or to send transactions to the network to change data that is stored in the contract. So from here on out, it's really going to be an issue of figuring out how to work with the lottery contract inside of the app component. I think that a good first place to start will be to try to get the address of the manager of the contract. Remember that our lottery has a manager property, and that's the address of the person who created it. So let's figure out how we can get that piece of information off the contract and then somehow render it inside the component. In order to get any information off of our contract and render it on the screen or render inside this component, we're always going to follow the same sequence of actions. So here's what we're going to do. We're going to always let our component render. We are going to define the component did mount lifecycle method. Inside there, we will call whatever methods we care about on the contract to receive or fetch some amount of information, and then we'll set the data that gets returned on our component level state, and then show that inside the render method. Now, one quick thing, if you went through that quick introduction to React a couple videos ago in the appendix, you might not have heard about the component did mount lifecycle method. This is a lifecycle method. If we define it on our component, it will be automatically called after our component is rendered to the screen. So it's a great place to load some data or do any other type of activity that needs to be done one time when a component first renders to the screen. So let's give this a shot. I'm going to change back over to my editor. I'm going to define the component did mount lifecycle method. Because this method is called component did mount, it will be automatically called whenever the app component is placed on the screen. Now inside of here, we can attempt to fetch some information off of our contract. So I can say, just like we said inside of our test file in the last couple of videos or in the last section, we can say const manager is await lottery.methods.manager.call. Now, one thing I want to point out here, whenever we are in the Ethereum world inside of a React application, and whenever we are making use of the MetaMask copy of Web3 rather than our own copy, or I should say, whenever we're making use of the provider from MetaMask, as we spoke about just a little bit ago, we don't actually have to specify where this call is coming from. So you'll recall that previously inside of all of our tests, we always said something like accounts at 0. Whenever we're making use of the MetaMask provider, we don't have to specify the from field right here because this copy of Web3 or the provider has a default account already set. And it's going to be the first account that we are signed into inside of MetaMask. So in this case, it would be my account 1. So again, whenever we are writing React code and working with the MetaMask provider, we don't have to specify this from property. So we can leave it as simply call, like so. Notice that we are using the await syntax here, so we do have to mark this component did mount as being async. And then immediately underneath this, we can then set our state for a property that we will call manager. So I'll say this dot set state, manager is manager. And of course, we can use a little bit of ES 2015 syntax to condense this down to simply manager, like so. Whenever we make use of state, we do typically want to define our state variables ahead of time. So up inside of a constructor method, we'll say constructor with props, we'll add in super with props, and then we can say this dot state has an initial manager property of empty string. Cool, so this looks good. But let's now try making use of this manager property inside the render method. So down inside of render, I'm going to find all the JSX that it's already here. I'm going to highlight all of it, and I'm going to delete it all. So we're going to replace this with our own block of JSX. We'll place a div. Inside there, we'll place, how about an H2, and we'll just very loudly declare this is our lottery contract. And then we can place a little bit of information about the contract. In particular, maybe the address of the manager. So how about a paragraph tag with a text, this contract is managed by, and then this dot state dot manager, like so. All right, let's very quickly run through the order of operations that's going to occur whenever our application runs inside the browser. Our application is going to load up. The app component will be rendered to the screen. That will cause the render method to immediately be called. We'll take this JSX and put it on the screen. During this initial render, this .state.manager will have a value of empty string because that's what we defaulted it to up here inside the constructor method. After that, the component did mount method will run. We will make a call to the network to retrieve the current state of the lottery contract, in particular the manager's address. We'll then set that state on our component. That causes our component to automatically re-render. That will cause the render method to fire again. And now we'll re-render the component with a defined this.state.manager property. So let's flip back over to the browser and see how our app is doing now. Okay, so let's zoom in a little bit. This looks good. So we've got lottery contract, and it says very clearly, this contract is managed by blah, blah, blah. And that right there is my address, as I can double check very easily inside of MetaMask. So there we go, CF019. All right, fantastic. So that's our first taste of retrieving some information off of a contract and displaying it inside of a React component. Honestly, it doesn't get much more complicated than this. This is a pattern right here that we're going to be repeating over and over and over again as we try to work with data off of a contract. The only other thing that we really have to figure out here is how we deal with sending a transaction to a function, or a function that changes some data that is stored on the blockchain. So we still have a good amount of work to do, so let's continue in the next video and start pulling off some other information off of our contract. In this video, we're going to make a little change to our app component. This is a change that is not related to React, and it's not related to Ethereum. Instead, this is a change that is brought about with a new version of ECMAScript. So this is a ES 2016 change that we're going to make. In the last video, we had defined the constructor method for the sole purpose of initializing our state object. We gave it a property manager that defaulted to be an empty string. Now inside the constructor, we're really not doing anything besides initializing our state object. With ES 2016, we can refactor this constructor method right here to be a little bit more succinct. So let's do the refactor and then we'll talk about what happened. I'm going to highlight the entire constructor method and delete it. And then I'll replace it with simply state equals and then curly braces like so. And then inside of here, I'll say manager is empty string. I'll then save this file. So what you see right here is 100% equivalent to the code that we just had on the screen 2 seconds ago. If you define some apparently variable inside of the class body, this declaration right here will be automatically moved to the constructor method. So you can kind of imagine that after all of our code right here runs through Babel and is converted to ES5 code to run inside the browser, you can imagine that this statement is taking place inside the constructor. So these two forms of syntax are 100% equivalent. This is a way of creating our state or initializing our state that we're going to be making use of quite a bit throughout the course. So I wanted to spend one video on its own to talk about this refactor because you're going to see this pattern repeated several times. All right, so let's pause here and continue in the next video and start pulling more information off of our contract. We've got a great pattern for fetching information off of our contract now, so let's pull some other properties off of our contract and then get them to display on the screen. If we go back to our mockup, you'll recall that we wanted to show a couple other things to the user. So we probably want to show how many people are currently entered into the contract and how much money is at stake to win. So we need to fetch off both the number of players who are currently entered, and we also need to get the balance of the contract. These are both things that we've done in the past several times, so I think this will be a pretty quick little task. Inside the component didMount method, I'm going to add on another variable here. We'll call this const players, and this will be coming from lottery.methods.getPlayers.call. The getPlayers method is a function that we had defined back when we were writing our contract inside of our lottery file. So here's my code editor with the lottery contract right here. Here's the contract, and you will recall that at the bottom we had defined getPlayers, and that returns the entire array of addresses for every player who has entered. So we're going to take this array of players right here, and we'll add it on to our state object. Of course, since we're adding on this additional property to state, we should probably initialize the property inside of this class instance right here, or excuse me, the instance level property. So I'll say players is going to be an empty array to start off. And then finally, I think that we need to get the balance of the contract as well. And we should print out the balance because that's going to be how much money is at stake to win if someone wins the contract. So underneath the players, we'll get balance, and this will come from web3.eth.getBalance. Again, you'll recall that we used this when we were writing our test just a little bit ago. We call getBalance, and then we pass in the address of the account that we want to get the balance for. In this case, it's going to be the address of our lottery contract. And recall that we can get the address by referencing lottery.options.address. Again, this right here is something that we saw when we were writing our tests a little bit ago as well. Let's make sure we add balance onto our state. And then we should also initialize balance to be an empty string too. Now in this case, remember that balance right here is supposed to be a number in way, but you'll notice that I initialized it to be an empty string right here rather than a number. This is something we haven't really spoken about just yet in this course, but this object right here, balance, is not actually a number. It's actually an object. It's a number that is wrapped in a library called BigNumber.js. Again, this is something we haven't discussed yet, and we're not going to go too deep into it right now, but we'll get a good sense of what this big number thing is later on. So suffice it to say, for right now, we're going to initialize balance as an empty string. All right, so let's now take these two new properties and use them inside of our render method. So inside of our p tag, let's give ourselves a little bit of space, and then we'll say, let's see exactly what we had printed on here. So we should be saying there are currently blank people entered competing to win some amount of ether. So there are currently this .state.players.length people entered competing to win. Did I spell that right? Competing, yep. Competing to win some amount of ether. And that ether is going to be this .state.balance ether. Now just hold up a second here because this right here, this .state.balance, isn't exactly correct. Remember that this is going to be the amount in Wei. And we don't really want to print out this gigantic number in Wei. It'd be a lot more meaningful if we printed out the value in Ether. So we will again use the Web3 utils module to convert this from a value of Wei over to a value of Ether. So I'm going to replace that with web3.utils.fromWei. Notice that this method name is different than what we were using before. In the past, we were using toWei for whenever we wanted to convert from some units over to Wei. In this case, we're going from units of Wei over to some other type of unit. So that's why we're using this slightly different method here. So now we can do this.state.balance. And then as a second argument, we need to specify the units that we want to see. So we want units of Ether, like so. All right, let's save this and see how we're doing now. I'm going to flip back over to my application inside the browser. And all right, so we've currently got 0 people entered, and they are competing to win 0 Ether. So that's definitely what we expect to see right now. And we're not going to see these numbers change until we eventually get the ability to actually enter into the lottery. So it seems like that's going to be something that's very relevant. So let's start working on giving our users the ability to enter in the next video. Our application is now showing some information about the current state of our contract. However, we don't yet have the ability to actually enter into the lottery. So in this video, we're going to start working on getting a little form to show up that our users can make use of to actually enter into the contract. Putting this form together will be pretty straightforward. We'll place a form tag, we'll place an input, a label, and then an actual button for the user to click. And whenever the user clicks on this thing, we'll make sure that we attempt to enter them into the lottery. So let's get started. Inside my render method, I'm going to find the existing paragraph tag that we have, and then underneath that, I'll add in a horizontal divider, so an HR tag. This is simply for stylistic purposes. It's just to get some separation between the different elements in our application. Underneath that, I'll add on a form. Inside there, let's put in a H4. That specifies exactly what's going on with the form. So how about we say something like, want to try your luck? I think that's reasonable. And then underneath that, we'll place a div, and inside of here will be our label and our text input for the user to specify how many Ether they want to contribute to the contract. So let's do a label, and we'll give this the text amount of Ether to enter. Then we'll place our input. This is going to be a controlled input, so we're going to specify both the value and the onChange events tied to it. So we'll give it an onChange event handler that will be called anytime someone changes the text in the input. So we'll give it an onChange that takes in some event, and whenever this thing is called, we'll run this.setState, and we'll update a property that will hold the amount of Ether that this user wants to contribute. So let's call that property, how about value? Because that's what it's actually called when we make our transaction to send this money in. So this will come from event.target.value, like so. We also need to make sure that we set the value of the input itself. So we'll say value is this.state.value. All right, so that looks good. Let's not forget to initialize our state.value property up at the top of this component. I'm going to go up to the top. Here's our state object, and I'll initialize the value property to be empty string. Now again, we're not making a use of a number here, but this is for a different reason than balance. In this case, we are setting value to be empty string because a text input is always going to be empty string inputs, or it's going to be a string that we are working with. All right, let's go back down to our render method. I think the last thing that we need to do inside the form itself is to add a button for the user to click to enter into the contest. So we'll add in a button still inside the form, and we'll give it the text enter. All right, let's save this and take a look at our form and just see how it's working. Back over inside the browser, we get our refresh, and okay, well, Hey, it doesn't look great, but it definitely looks like exactly what we need. So now we can type in the amount of ether, and then we can click enter if we wanted to. Of course, right now we don't have any event handler hooked up to the enter button or form submittal in general. So let's pause here. We'll come back in the next video and make sure that whenever this form gets submitted, we attempt to enter the user into the lottery. We've got our form on the screen, and now we need to make sure that whenever it gets submitted, the user gets entered into our lottery contract. As you and I very well know by this point, when we say enter into the contract, we really mean send a transaction to the enter function on our lottery contract. That's what we're trying to do. So let's go back over to our code editor. Here's our form element. Let's add an event handler that watches for the submit event on the form. We'll then define that event handler and write some code in there to make sure that anytime this thing gets submitted, we call the appropriate function on the contract. So I'll say onSubmit equals this dot onSubmit. So you and I are going to make a function called onSubmit that's going to be used to actually call the lottery contract. Let's now go up outside the render method and we'll add that event handler in. So I'll say on enter like so. Or do we call it onSubmit? Did I just make, oops, sorry, onSubmit. My mistake. OnSubmit like so. Now, one thing to be aware of, whenever we are making use of an event handler with React, we always have to worry about the context of the function. And when I say context, I'm talking about the value of this. Traditionally, we have made use of techniques like calling this.onSubmit.bind this. However, with the version of Babel that is running inside the Create React App starter pack, we get another little benefit or another little piece of syntax to keep us from having to worry about manually binding the function. So rather than using this syntax right here to define onSubmit, we're going to use a slightly different syntax for defining this function. We're going to instead write out onSubmit equals and then an arrow function. So when we use this syntax right here, it's still defining a method on the class, but we don't have to worry about the value of this inside of the function, as we normally would with a method. The value of this will be automatically set for us to be equal to our component, which is exactly what we want. So we don't have to worry about binding onSubmit down in the render function. All right, so let's get back on track now. Whenever onSubmit gets called, it'll be called with an event object, and that event object represents the form submission. As usual, we want to make sure that the form does not attempt to submit itself in the classic HTML way. So we're going to start off by calling event.prevent default. Oops, default, like so. Then inside of here, we can start to write out the code to send a transaction to the enter function. That's definitely going to involve some asynchronous code, so I will be sure to mark this function as async, like so. Then we can start to write out the actual transaction. One thing that I want to mention before we write the transaction, a couple of videos ago, I had mentioned that whenever we are making calls in this sort of JavaScript React world that uses the provider from Web3, we don't have to make use of that from property and specify which account we are sending this transaction from. Now that is true with calls. However, with the version of Web3 that we are making use of here, unfortunately that is not true of sending transactions. So when we send a transaction, we unfortunately do have to retrieve our list of accounts from the Web3 object and then specify the account that is going to be used to send money over to that particular function that exists on our contract. So long story short, before directly calling the lottery contract send or enter method, we have to get a list of our accounts. Now we've gotten a list of our accounts in the past before. Recall that we can call const accounts await web3.eth.get accounts. So we did that just a little bit ago inside of the render method of our component. When we did it previously, we didn't make use of the async await syntax, but in this case, because we are in a function that is marked as async, there's no issue with taking that approach. All right, so now that we've got our list of accounts, we're going to assume that the first account inside this array is going to be the account that is going to be sending the transaction. So with that in mind, we can then write out the actual statement to enter our user into the lottery. So we'll say await lottery dot methods dot enter dot send. And then just as we are very used to by this point, we need to specify both a value property and the from property. So from is definitely going to be accounts at 0. Again, we are assuming that the first address inside of our list of accounts is the one that is going to be used to enter into the lottery. Then we're going to also specify the value property, which is going to be the amount of money that we want to enter into the lottery contract. So this is going to come from the property that we've been setting inside that input that we put together in the last video. So here's the input right here. The property that we care about is this.state.value. Remember that this right here is a value in Ether. So we need to first convert this over to Way before we send it into the transaction. So back at on submit, we're going to specify this.state.value, and we're going to make sure to convert that over to Way. So in front of this, we'll put web3.utils.toWay. And then of course, as a second argument, we also need to specify what units this.state.value is using. And so that's going to be Ether, like so. All right, so this is going to enter us into our contract. But as we said several videos ago, this is sending a transaction to the network, and that's going to be something that takes 15 to 30 seconds, or at least some amount of time. So we really want to provide some feedback to our user and tell them, hey, we're currently doing something for you. Like, we are entering you into this lottery. And then ideally, we should also send them a message that says something like, hey, you've now been entered after this function has been successfully executed. So I think that to add on this type of messaging thing to our user, we can make use of the state system inside of React again. So let's take a quick pause here. We'll come back in the next video and we'll start putting together a little piece of state message so we can communicate what's going on to our users. We finished up the last video by discussing how we should probably communicate what's going on with our application to our users. So right before we call our send function right here, we're going to create a new piece of state. And we'll call this something really simple, like how about something like message. So we're going to have a message property that we're going to display inside of our render method. And this message thing will tell our users exactly what's going on with the current status of the application. So right before we attempt to send a transaction into the network, let's say waiting on transaction success, like so. So now it will be very clear to our users that if they submit the form and then we submit this transaction right here, right before the transaction gets submitted, we'll give a message that says, hey, like, we're just hanging on right now, just give us a minute. In a little bit, once the transaction goes through, we'll then be able to say that you were successfully entered. So after this transaction is approved by the network, we'll then update our message. We'll then say something like, message with you have been entered, like so. Now, to be 100% clear, when we say that it takes, say, 15 to 30 seconds for a transaction to clear the network, we're talking specifically about this line of code right here. So this right here is going to take 15 to 30 seconds or so to actually be processed. So even though it looks like these two statements occur one after another, there's definitely going to be a significant delay in time in between the two. So now we've got this new message property. Let's not forget to first initialize it at the top of this component, and then we'll place this thing inside of our render method so that our users can see what we're actually writing to them. So up at the top, we will initialize our message property. Then down inside the render method, we'll place this.state.method. So how about at the very bottom, underneath our form, let's place another horizontal divide, horizontal rule. And then underneath that, let's do an H1 with this.state.message. So now it's going to be really, really, really clear what's going on. All right, I think we're ready to test this thing out. So back inside the browser, we'll let the refresh happen. So here's the horizontal rule. Whenever we get a message, we should see it appear underneath this line right here. So let's enter in some amount of Ether to enter into the lottery. I'm going to use just 0.01 Ether, and I encourage you as well to put in some rather small amount here. But you know what? I just realized we do have a minimum contribution on our contract. So let's double check what that is. So here's our contract source code. All right, so we had said that it had to be greater than 0.01. So I actually can't use 0.01 right here. I have to use something like 0.011. So now we should be able to click the enter button, and that will enter us into the lottery. So I'll click on enter. We see that message appear at the bottom that says waiting on transaction success. And then we get a confirmation message that's popped up to us by MetaMask. We saw this message right here in the past once before. So of course, MetaMask wants to make sure that before it starts making use of any of your money, it gets your very direct approval. Anytime that we try to send a transaction that works with some amount of money into the network, MetaMask will pop this thing up and expect to see a submit button click from the user. If the user clicks anything else, then it will return an error to our application. And in theory, we probably want to write some code to make sure we handle that error appropriately. So for example, if on this transaction I click reject, you'll see that I get a big red error message down here. And as a matter of fact, the entire application essentially crashes. And it says specifically, user denied transaction. So user said, nope, you're not sending my money. We can refresh the page, and then this time we'll click submit to make sure that the thing actually works. So I'm going to again enter in 0.011. I'll enter it. This time I'm going to click on submit. And now we basically wait for those 15 to 30 seconds. All right, so many videos ago, I had mentioned to you, and I've mentioned it several times since then, yeah, it takes some amount of time for this stuff to occur. So here we are waiting for a transaction to be approved by the network. You have to make sure that your users are aware that that is occurring right now. Because I can tell you, I can guarantee you that in the real world, if a user clicks on submit, or they click on enter, or something that should make a change to your application, their expectation is that the change should happen nearly instantly. Because that's what they're used to with every other UI out there in existence. Everything from email to eBay to, I don't know, image sharing services. You click submit and something instantly happens, or near instantly. However, as soon as we start working with Ethereum, we have to wait for these 30 seconds. So we gotta make sure that our users are aware of what's happening. Otherwise, they're going to assume that the application is broken. And that's definitely a very bad thing. All right, so my spiel right there took about 15 or 30 seconds, and you'll notice that now it says you have been entered. Awesome, so that's exactly what we wanted. Now we should be able to refresh this page, and when we do, we will refetch the number of people who have entered and the amount of money that is contained inside the contract. So we should see those two numbers update from 0. So I'll click refresh. And now when the page reloads, we see that there's currently now one person entered, and they are competing to win 0.011 Ether. Awesome. All right, so that's pretty much the entire flow, believe it or not, of start to finish of an Ethereum contract. We've now seen the two very basic but very core interactions, reading data off the contract and writing data to the contract. Everything that we do from here on out is going to be absolute repetition of those two same techniques, again and again and again. We're going to read some data, we're then going to take some user input and write it back to the network. And then we're going to wait for that transaction to succeed. Of course, our application right here still needs a pretty good amount of work. So let's take a break and continue in the next video. Our users now have the ability to enter into our contract. However, we do not have the ability to pick a winner. So in this section, we're going to start working on this little additional element down here. We should have a button that the user can click. Whenever they click it, it should execute the pick winner function on our contract. Recall what we had said when we last looked at these mocks, by the way. We should only really be clicking on this button if we are the manager of the contract. Now, certainly we could figure out some way to only render this section if the user who is viewing the application at this point in time is the manager. However, for this simple application, this pretty straightforward one, we're just going to say, you know what, everyone can see this button, everyone can click it. Of course, if you click it and you're not the manager, you're going to get an error message. But again, for this first time around, we're going to keep things nice and simple. All right, so let's get started. Back inside my code editor, I'm going to find the render method towards the bottom of our component. I'll then go down to the bottom of the render method, and we're going to place a new HR that's going to serve as the section boundary for this new little pick a winner functionality. So here's the bottom HR. I'm going to put a new HR in right underneath that. And then between these two HRs, we'll place an H4 that describes what this section is for. So we'll say, ready to pick a winner. And then underneath that, we can place a button tag for the user to click on. Let's give it the text something like, pick a winner. And then we'll also need to hook up an event handler to the button. So let's set up a on-click event handler. Whenever someone clicks on this thing, we'll run a function that we'll call this dot onClick. Notice that we're not using a form here because we don't have any inputs or anything like that to work with. We have just one simple button. So if a user clicks on this thing, we just want to go ahead and call the pick winner function on our contract. Let's now define the onClick function inside of our component. So I'm going to scroll up above our render method. So right here, we'll define the onClick method. And this will be called anytime someone clicks on the pick winner button. We're going to use the same syntax that we used just a little bit ago with onSubmit so that we can avoid having to worry about the context of the function. So we'll say inside of here, onClick is async and then an arrow function. Now the contents of this thing is going to look very similar to what we just wrote a minute ago inside of onSubmit. And in fact, it's going to look nearly identical. We're going to get a list of accounts. We'll set some message to tell the user that we're about to do something. We'll then send a transaction to the network. And then after that transaction is complete, we'll then tell the user that, hey, a winner has been picked. All right, so inside of onClick, we'll first start off by getting a list of all of our accounts. So we'll say const accounts is await web3.eth.get accounts. Don't forget the await keyword right here, really easy to miss that one. We'll then try to call the pick winner function on our lottery contract. So I'll say await lottery.methods.pickwinner.send. For this method, or for this function I should say, the pick winner function, recall that we're not sending in any money or anything like that. So all we have to do here is specify exactly who is sending in the transaction, or in other words, the source account. So we'll say from accounts at 0. Now right above this thing, we'll add in a little bit of messaging to our users. So we'll say this.setState for message. And this is going to be kind of like the pending message where we tell the user, hey, just hold on for a second, we're waiting for the transaction. So let's use the same text that we used before just to be consistent. We had said waiting on transaction success. So let's do the same thing here. Waiting on transaction success. And then underneath this thing, we can place a message to tell the user that a winner has been picked. So we'll say this.setState message, a winner has been picked, like so. All right, now one thing that you might be kind of curious about, well, it would be really fantastic if we could somehow tell our users exactly who just won the contract or who just won the lottery. However, remember that we are sending a transaction to this function. And whenever we send a transaction, we get no return value back. So we have absolutely no ability right now to be told who just won the lottery. We can't do it. We could say maybe look up some transaction logs around our contract and see where the contract has sent money to. That's a little bit burdensome. Maybe a better way to approach this, a better way to figure out who just won the contract, would be to go back over to our contract source code. So here's the contract source right here. And maybe whenever we call pick winner, maybe we set up some variable on our contract and say we record the address of the person who last won the lottery. So maybe in theory we do something like last winner equals players at index inside the contract. This would definitely work right here. So we could pick a winner and then we could read the value of last winner and display that on the screen. That's certainly an option. However, I'm going to leave that up to you if you want to try that approach. For us, I think that we're going to stay nice and simple and simply say, hey, a winner has been picked. And it will be up to our users to kind of figure out, oh, okay, either I did win or I didn't win. To be honest, at the end of the day, it's going to be pretty obvious who won and who didn't win because you can always just check your MetaMask balance right here. And it will tell you, okay, you've either got money or you lost money or whatever it might be. All right, so let's take a quick glance at our code again. So we've got our listing of accounts. We set up a waiting message. We send in the transaction. And then after the transaction is complete, we then display the text, a winner has been picked. I think this is looking pretty good. So let's flip over to the browser and do a quick test. Back over in the browser, I'll refresh very quickly just to make sure I've got the latest code inside of here. All right, now I'm going to click on the Pick a Winner button. When I click on Pick a Winner, we get the confirm transaction message again. Of course, this time we're not sending along any money with this transaction. However, even when you send in a transaction with no money, MetaMask still asks for your approval, because anytime you send a transaction of any kind, it costs gas. And of course, gas costs money. So MetaMask wants to make sure that our application is not trying to maliciously send in some transactions. That's why you see this window right here asking for approval. So again, we'll click on the Submit button. And then we sit around and twiddle our thumbs for another 15 to 30 seconds. As I've mentioned many times, and I'm sure it's getting very repetitive, yep, this is the point at which we would want to give our users some very clear messaging and say, okay, like we're processing, we're picking a winner, and very shortly you will figure out who won. This time around, it's going to be pretty simplistic because, hey, we've only got one person inside of our contract. And so it should be my account that wins and receives the 0.011 Ether back. So down here, you'll see that the text updates to say a winner has been picked. Now, if we refresh the page, we should see the contract revert to say 0 people have entered, and we should also see it say that there is 0 Ether in competition. So we'll refresh. And now we're back to seeing 0 people have entered and 0 Ether is available to be won. All right, so that's pretty much it. That is our first little contract. That's the first web application to work with our Ethereum code. So let's take a break here and we'll talk about some additional topics in the next video. In this video, we're going to do a quick review of the application that we just finished up. I think you'll agree with me that the React side of this app came together really quickly. Once you put together all the logic for your contract, honestly, the React part isn't always so bad. Most of the time, we're just accessing different functions on the contract, pulling off some data, and maybe modifying some data in 1 or 2 places. So let's do a quick review of how this component works. First off, we have only one component inside of our application. It initializes 5 different properties of state: manager, players, balance, value, and message. Some of these are properties that are utilized by the contract itself, or at least coming from the contract. Others are being produced by the component itself, as is the case with value and message. As soon as our component renders for the first time, the component did mount lifecycle method gets called automatically. Inside there, we pull off a couple of different factors or properties off the contract and then set them on our component state. We then later utilize these different properties inside the render method. Again, this is a very reproducible pattern right here, and I think on your own, you're going to have an easy time pulling data off a contract and displaying it inside of a component. Things got a little bit more complicated when we look at some of our different event handlers, such as the onSubmit handler and the onClick handler. Each of these retrieved a list of active accounts that are being provided by MetaMask. They set a waiting message and then called a function on the contract. Again, this is a lot of code that we wrote already inside of our test file when we were initially developing our contract. That was the case with onClick right here as well. And the only other thing that we really did inside this component was the render method. The render method read some different properties off of state and displayed them on the screen. I think the only other thing of note inside of here is that we made use of the fromWay function, which is used to take a way value and convert it into some other denomination. In this case, Ether. That was pretty much it. So I don't think there was a whole bunch else with the React side of this project. Now, of course, with this project, we took a lot of corner cutting. Like we did a lot of shortcuts. For example, we are displaying the ready to pick a winner button, even if the person viewing this component is not the owner of the application. We're also not doing any error handling around clicking the button. We're not doing any validation of inputs, say on the amount of Ether that we are entering. So for example, if I enter in some text like so, and then click enter, yeah, of course we get a big nasty error message awfully quickly here. So there's still a little bit of work that can be done, and certainly still a lot of polish that we need to learn as far as taking a contract goes and putting it into a React project. But that's going to be what our next project is for. Our next project is going to be all about building a production style application that we would feel very comfortable and very confident deploying in the public and in the wild. So let's pause here and continue in the next video where we're going to start working on our next contract.